Trigonometric identities, Pythagorean identities for reciprocals. Well, this is a part of second set of identities which you should know to prove trigonometric identities. Okay, and here is a small proof of the same. It is very similar to what we did for sine square theta plus cos square theta equals to 1. I'll appreciate if you go through these 5 set of videos in a sequence to understand all these basic rules to prove trigonometric identities. Okay, that'd be great. Now here, to prove it, we'll just take help of our good old right triangle. Okay, now here is my right triangle. So in this triangle, I'm calling this as my opposite side, that is my adjacent, and this is my hypotenuse, correct? And I have an angle theta here which moves counterclockwise from x-axis. That is my angle theta, correct? And this is right angles. This is any coordinate from where I've dropped a perpendicular to x-axis and got a triangle, correct? Now in this triangle, you will see one thing. It's a right angle triangle. Therefore, always O square plus A square is H square, right? So let's start with that. So we have O square is opposite side plus A square, the adjacent, equals to hypotenuse square, correct? That's a Pythagorean theorem, and that is why these identities are called Pythagorean identities. Okay, now what we will do is we will divide by something. So what that something happens to be is, so we will do divide by A square. So let's divide all of them by A square. Okay, so I'm using divide by. So I'm dividing both sides by A square. Look at it. Perfect. So when I do that, then what do I get? O over A whole square. What is O over A? That is tan theta, opposite over adjacent, right? So I can write this as, or if you want, I can write it in two statements. This is O over A whole square plus A over A is 1, right? So 1 plus H over A whole square. This is what I get. Is that okay? O over A whole square, A over A gets cancelled out, you get 1, H over A whole square. Now, opposite over adjacent is what? Opposite over adjacent is tan theta, right? So we get tan square theta here plus 1 equals to hypotenuse over adjacent. This is reciprocal of adjacent over hypotenuse, which is reciprocal of cos, and you get secant square theta. Do you see that? So we proved this identity, tan square theta plus 1 is secant square theta. Do you see that? That is an identity which we proved with the help of a right triangle. Do you see that? Now we'll do again the similar thing, okay, and see what I do this time. This time I will write this as A square plus O square equals to H square. So let me write this as A square. These are the two sides of the right triangle, plus O square equals to hypotenuse square, correct? And this time let me divide it by O. So if I divide by O square, what do I get? Now I get A over O whole square plus O over O is 1, right? And H over O whole square. Is it okay? Now what is A over H? A over H is, A over O. So what is A over O? A over O is cotangent, right? So I can write this as cot square theta and 1. And what is H over A? H over A is cosecant square theta. Cosecant square theta, right? So H over O. So that is what we got. And so our identity has been proven. Okay. I'd like you to remember SOHCAHTOA so that you don't get confused between secant, cosecant and sine. And SOHCAHTOA is sine is opposite over hypotenuse, and then we have cosine versus adjacent over hypotenuse, and then we have tan, which is opposite over adjacent, right? So that helps you to figure out what is what. So tan is opposite over adjacent, correct? Sine is opposite over hypotenuse. Reverse of sine is cosecant. So hypotenuse over O. This is cosecant. Hypotenuse over it. You get it? Cos is A over H. Reciprocal of cos is secant. Secant should be H over A. H over A is secant. That is how you relate it. So try to get used to these terms, right, before getting into proving trigonometric identities. I have about 100 examples here for you, okay? So get used to these 4 set of basic trigonometric identities so that you can prove any trigonometric identity, okay? All the best. Thanks.